Hello, everyone, and thank you for watching our video. My name is Szwargulski, along with Patrick Daly, Sean Nuzio, and Donovan, and today we're going to discuss smart factories. We'll talk about what a smart factory is, take a look at a case study, and discuss the drawbacks of implementation. What is a smart factory? Essentially, a smart factory is a cyber-physical system that integrates physical systems like CNC machines, robots, 3D printers, with information like the MES and ERP systems. The process of this integration can be broken down into three main processes: data acquisition, data analysis, and intelligent automation. Data acquisition refers to the collecting of data not only from the factory, but from the business systems as well. Data such as customer needs, marketplace conditions, logistics. Data collection is carried out primarily by AI and IIoT devices. AI will actually have a dual role in this process, and that it will be used to both collect and analyze the data. And on the shop floor, devices are interconnected via IIoT and reports performance and status. After collecting data, we move to data analysis. There are four basic types of analytics: descriptive, diagnostic, predictive, and prescriptive. Descriptive analytics are more traditional analytics we think of, like trend data and KPIs. And diagnostic analytics go a little bit deeper and try to determine root cause by way of correlations. In predictive analytics, as the name suggests, it is used to predict future events using predictive modeling and deep learning. Predictive analytics attempts to not only determine future marketplace trends, but also machine behavior so that inputs can be adjusted and preventive maintenance can be executed with minimal or no downtime. Prescriptive analytics informs on what should be done. On the enterprise level, would advise on business decisions like capital investments in future products, but also inform machine behavior on the shop floor. And finally, intelligent automation, where we link the data to the real physical world via machines that can take the data analysis and perform a function, and then also report data back and continue the loop. What are the benefits of smart factories? The major one is the improvement of quality. Automation reduces manual errors and real-time data and analytics to adjust process inputs. Flexible production, agile equipment for rapid product changes, and also increased efficiency, where productivity can be increased, predictive. Process optimization, and we can also decrease time to market.
Perfect.
Now we'll take a look at a case study.
Apologies, Chad. We're just going to dive into quickly a case study on BMW. So BMW is a German luxury car company. It's now the 14th largest motor vehicle producer in the world, with major production facilities in over 8 countries and subsidiary factories and suppliers in several others. With over 111 billion euros in annual revenue, BMW is at the forefront of emerging manufacturing processes since its inception. World Economic Forum actually called it the lighthouse of the fourth industrial revolution based off of its technology. Before we jump into some applications of BMW and smart factories, let's look at a brief manufacturing history of the company. Next slide, please. BMW started in 1916 as an aircraft engine manufacturer. At the time, it was utilizing electrified machines innovated from Industry 2.0, or the second industrial revolution, to mass produce their products. Workers manually ran each machine and transferred parts manually between each workstation. After some wartime production for the first 2 world wars, BMW bought out an automobile company, signifying its start as an automobile company. Assembly lines where unfinished assemblies are automatically transferred between workstations by conveyors found its way from Ford's Model T factories into Europe, where BMW incorporated this process into their production. Post-World War II, BMW did struggle as many of their factories were bombed in the war, and the rest were gutted by Allies as part of war reparations. They actually made pots and pans just to avoid bankruptcy for a couple of years. Once BMW was able to get back on their feet and get automobile manufacturing underway again, the beginnings of what is now known as Industry 3.0 were taken root. This included early computers, electronics, and their applications. Albeit simple and extremely large for their computing power based off of today's standards, BMW was able to utilize this technology to set the stage for automation and computer integrated manufacturing in their facilities. This era included the introduction of manipulator robotics, primitive programmable logic controllers, and really basic automation. This continued throughout the 1990s, where BMW sought to expand their company into a global endeavor. They also opened a research center, which led to advances in safety, production, and manufacturing features. The design plants now also based off of efficiency with a branched or comb design and incorporated supplier nodes into their factories to minimize the amount of time sub-assemblies travel around. Finally, as we near present times, BMW looks forward to the advancement of Industry 4.0 and the Internet of Things. This era, we're seeing mass data analysis, smart automation, AI, and machine learning, as these will all greatly improve manufacturing, ensure the quality of BMW cars. Next slide, please. So a large and really public portion of BMW and their use of Industry 4.0 right now is their Regensburg Smart Factory in Germany. BMW partnered with NVIDIA, which is a graphics and technology company, to use and create a digital twin that blends the real world with a virtual one. With NVIDIA's new Omniverse technology, it's a 3D platform with giant 3D design and development applications. BMW has simulated the entire Regensburg facility in a virtual reality, down to every single part, robot, assembly, even manufacturing operation. In real time, this AI facility gives the chance to simulate their production and explore how to create their production and manufacturing a lot more efficient. This innovations allow greatly improved flexibility and precision. It's by over 30% based on conventional manufacturing methods. This smart factory really does serve as an exemplar as industries and manufacturing as a whole trend in the direction of the fourth industrial revolution. Next slide. So even in other BMW facilities and production factories, the luxury car company still employs many factors of smart factories discussed earlier to manufacture their products. In each of their production shops, sensors, data, and computers and AI help to tailor each individual part with utmost precision and efficiency, while also monitoring the entire manufacturing process real time. For example, in BMW's press shop, steel rolls are unfurled and several sensors and gauges are used to measure any inconsistencies, deviations, or characteristics in each strip of metal. Each part is laser engraved with a unique part number, which is scanned at all parts of the production process and linked to individualized data on each of that said part. Each tailored piece is automatically delivered to the next location by use of smart delivery systems and conveyors. The body shop amounts of data from sensors in manufacturing equipment can measure the wear of machines and predict breakdown before they occur, streaming all of this data real time to maintenance workers that can monitor and fix equipment to minimize downtime. In the paint shop, it's equipped with a multitude of sensors that visually verify paint quality and finish, with custom data analysis systems to ensure the utmost quality. The assembly shop collects data on every single fastener, like measurements of torque and other data measurements. All this data is fed into an AI learning model to innovate future manufacturing production, as well as training any new staff. All of this data together is streamed into the cloud, allowing connectivity everywhere, not just on the factory floor. Next slide.
So now we'll look at the results that BMW has seen from this integration of technology. So looking back at that Regensburg factory, in 2018, they saw a reduction in quality issues by 5% and a reduction in time needed to deploy new applications, 80%. This was done through the use of 3D printing, for everything from 3D printing to smart data analytics. Overall, that factory produced 320,000 products that year. This is made capable with the Internet of Things, which links all the parts that are currently going through the factory to the machines, to the workers. So there are currently approximately over 3,000 linked machines, robots, and autonomous transports in the Regenberg factory. And the Internet of Things is what makes sure everything is connected seamlessly and running smoothly. And it alerts if there are any issues in the system on any of the parts. It can show where the issue is, perhaps what the issue is, and how it can be fixed. This helps decrease unplanned downtime and then helps increase worker safety and overall quality. The Omniverse, NVIDIA's technology, has now successfully been integrated into 31 factories, which have seen an overall reduction in planning time by 30%. In these factories, each factory line can produce up to 10 different cars. At 100 options for each car and 40 different models, that's approximately 2,100 ways to possibly configure a new BMW. So at BMW producing 2.5 million units per year, 99% of them are considered custom. BMW also regularly reconfigures its factories for new model launches. In the past, this has meant that employees have had to move from factory to factory to allow for an increase in production rate of this new model. However, with the Omniverse, this is no longer the case, and there is no longer a need for employees to move from space to space. And they are also able to simulate to-scale interactions using the Omniverse between employees and any machines or robotics or devices that are being used, even simulate down to the smallest interaction that they could possibly have. Again, just decreasing time that will be used throughout the day and increasing safety. Next slide, please. So now we'll talk about the impacts all this has had on the world. So we can see that smart factories like the Regenberg factory have the potential to add approximately $1.5 to $2.2 trillion to the world economy within the next 3 to 5 years. This is a significant increase from any impact that another automotive company has had on the world economy in quite a few years. However, in 2019, a private consulting company did conduct a survey of its manufacturers, and it found that only 42% of industrial companies, reported a worker shortage due to the new skill gap with the incoming technology. Workers that were previously unskilled working in these factories now found themselves incapable of working and interacting with the new technology that is required to complete their jobs. 14% of these manufacturers also said that they only 14% of manufacturers said that they considered their smart factories a success due to quite a few reasons, but one major one would be the worker shortage that they experience. Next slide, please. However, looking forward to the future, BMW does offer solutions for these issues. But their first step in the future would be to continue to integrate into the cloud. This allows for a more seamless connection between all the devices that are on the factory floor, which allows for faster processing, increased efficiency, overall greater safety and capabilities of all the machines and devices that they're using. Next would be expansion. So again, going back to that 2019 survey, the manufacturers that were surveyed, they said that there was going to be that they plan to have an overall 40% increase in the number of factories that they're going to open up in the next 5 years. This helps just expand throughout the world, and then that helps further increase the impact that these factories are having on the global economy. Next is the BMW mission statement, lean, green, and digital. So lean stands for high flexibility production. They want to continue to integrate more processes that will give them more variability in their production and more models that can be produced on a single line. Greater agility to them means a more competitive market. Next is green. They want to continue to stay and to work as an environmentally friendly company. Currently, BMW already sources exclusively green electricity from its suppliers and produces according to circular economy principles. Furthering this, they're opening a new plant in Hungary in the year 2025. This will be the world's first completely CO2-free automotive plant. Finally, digital. This touches back to the cloud. They just want to continue to push the limits of technology and see how far they can take it to be completely efficient and safe and work on their products. Finally, the training center. This is BMW's response to the lack of employees due to the new skill gap. They're opening up new training centers to be able to train current and upcoming employees on the technology that they would need to use to complete their jobs. So these training centers, currently the largest one has over 40 functional learning spaces. It has training areas to learn hand-on training of welding, metal fabrication, and machine tools, as well as advanced technical training in robotics, controls, mechatronics, and automotive technology. And it's just a great space for them to increase their workforce and to avoid job loss. Next slide, please.
So while there are many great things being done with smart factories, there are also drawbacks of implementation that have to be kept in mind, mainly those being upfront costs, which delay profits of the company, workforce implications, as a large number of employees tend to lose jobs in digitization, and environmental impact, as heightened production levels accelerate waste produced. Next slide, please. So first up on upfront costs is the investment in new technologies, such as the BMW simulation processes discussed before. While incredible from a technical standpoint, investment in Industry 4.0 is an expensive endeavor, including the cost of not only the implementation, but also the research and development of these technologies. There also comes with it the adjustment of normal processes. With new machines come new skills and procedures for employees to understand, and workers need to be retrained for these new processes, which often result in full turnovers, as partial adjustments are not nearly as effective. Both of these aspects are extremely time consuming for the company, as the conception and adjustment periods drain money through salary workers not being able to work properly and products not being produced during this time. Next slide, please. The increased use of automation will also affect the number of workers needed on site. And we do not know currently what happens to those who lose their jobs to the machinery. As you can see on these charts, manufacturing has been increasing over the past few decades by substantial margins. However, manufacturing jobs are falling as well. This is a result of the robots sort of taking over that assembly and design process. Fully automated systems will always be able to outpace handcrafted assembly and production. So justifying the use of manual labor can become a tough choice for a lot of companies. Where do these people go when replaced? It's not known currently. You know, these jobs are being replaced, and as more and more large companies decide to move towards full automation, these more and more jobs will disappear, leaving behind a large workforce. Next slide, please. Finally, there's environmental implications. You know, while companies like BMW are making efforts to remain carbon neutral, higher levels of manufacturing will inevitably have a negative impact on the environment. Increased level and efficiency of production as demand rises leads to higher levels of energy needed for instruments that are used in this way. And with these higher level of energy and more production comes increased waste from both factory use and transportation of goods. While the increased production rates per day are beneficial for profits for the company, it has worse implications in the long term. Next slide, please. Despite that, though, we believe that smart factories for large manufacturing companies are still a positive in the long run. They provide a wide variety of benefits to growing companies that produce much more efficient production and to reduce costs and increase profits on a macro scale. Implementation of smart factories has already shown to be successful through examples such as BMW, as trillions of dollars have already been added to the global market as a result. However, any company that is looking to make these changes has to keep in mind the drawbacks of doing so. These smart factories are not necessarily the right option for everyone based on the scope and nature of their businesses. Next slide, please. Thank you all very much for listening. I hope you have a wonderful day.